Today we will be in Chapter 4, Section 4, Slope-Intercept and Point-Slope Forms of a Linear Equation. Our two topic objectives for today are to use the slope-intercept form to determine the equation of a line and to use the point-slope form to determine the equation of a line. Chapter 4, Section 4, Slope-Intercept and Point-Slope Forms of Linear Equations. Before we get started in this section, I feel like this section is one of the more important sections of the entire semester, and it really, if you don't understand this section, it's going to make the rest of this course and Math 30 and college algebra or whatever math you take after that quite a bit harder. So I know this kind of falls towards the middle of the semester, and it can be kind of where you hit your slump. So if you've hit your slump, I ask for your undivided attention during this section just because it is that important, and it does have a lot of really integral parts in this section. Okay, so the first thing on the page is the standard form, which you've seen before, and that's ax plus by equals c, and that's just the standard form of a line. But the form of a line that you're really going to interact with probably the most is something called the slope-intercept form, and that is y equals mx plus b, and this is with m equals the slope and y in your y-intercept equals 0, b. That's what that b stands for. And you're going to use this probably more times than not, and this is actually what you've seen most of your equations in already, and you just may not have known it was called the slope-intercept form. So let's do a few examples. I have some examples of equations, and I want to find the slope and then the y-intercept of these. These are all written already in the y equals mx plus b form. So for the first one, we have y equals 4x minus 6. So my slope is my m. So my m in this case is 4. So my slope is 4. And then my y-intercept would be 0, and then b. But what's my b in this case? It's minus 6. So from this form of equation, from your slope-intercept form, you really have everything that you need to plot that. You can plot this point and then use your slope to find a second point, and then you already have the graph of your line. That's why this form is so easy and so nice to use. Okay, for our second one, we have y equals 1/2 x plus 3 over 2, just 3 over 2. So my slope would be 1/2, and my y-intercept would be 0, 3 over 2. Okay, y equals negative 5x plus 3. My slope would be the negative 5, and my y-intercept would be 0, 3. My last equation is y equals 2x. My slope would be 2, and then my y-intercept would be, well, what's my b in this case? Well, if you look at our equation, there's no plus or minus anything out here, so that would be 0. My y-intercept in this case would be 0, 0. I wanted to make sure that one was on here because I'm pretty sure that one comes up, if not in your homework, then on one of your exams. Alright, let's work a problem. Here's an equation that's in standard form, and we need to write it in slope-intercept form. So we need to write this so that it looks like y equals mx plus b. Well, if you notice, in slope-intercept form, the y is by itself. So that's all you need to focus on, is getting the y by itself. So let's add the 3x to both sides, and that'll leave us with 4y equals 3x plus 8. We still need to get this y by itself, so we need to divide by 4, which will give us y equals 3x plus 8 divided by 4, but we don't usually leave it like this. Usually we take each part divided by 4. So that'll be y equals 3 over 4x plus, and then 8 over 4 would be 2. So our final answer would be this. Alright, so that's how you go from standard form to slope-intercept form. The next thing we're going to do is very similar to stuff we've been doing in 4.3, where we're going to determine if two lines are parallel, perpendicular, or neither. The difference is that we have equations of lines this time instead of just the slopes. It's really easy to determine if lines are parallel, perpendicular, or neither if they just give you the slope. But if they don't give you the slope, then it's a little bit harder. So what you need to do first is you need to write these as y equals mx plus b, and then you can determine what your slopes are from those. So for this first one, all we have to do is subtract over our 2x in order to get that into y equals mx plus b. So then my slope would be -2. Okay, let's figure out what it is over here. We need to divide everything by 2 in order to get the y by itself. So it'd be y equals -4 divided by 2 would be -2, and then 5 over 2. So my slope for my second equation would be -2. So slope is -2, slope is -2. My slopes are the same, so that means my lines are parallel. Okay, what about my next ones? We have 3x minus 2y equals 7, and 6y plus 4x equals a -6. Again, let's just get these into y equals mx plus b. So we'd have -2y equals a -3x plus 7. Got to divide everything by a -2y. So just a -2. So y equals a positive 3 over 2, because that was a negative divided by a negative, x minus 7 over 2. So then my slope was 3 over 2. And over here we have 6y equals a -4x minus 6. Divide everything by 6. -4 over 6x minus 1. Now 4 over 6 reduces because you can take a 2 out of each of those. So we get y equals a -2 over 3x minus 1. So my slope for my second equation would be a -2 over 3. Now these aren't the same, but they are negative reciprocals. And if you're the negative reciprocal, then that means the lines are perpendicular. Okay, so let's do a third example. We have 2y minus 3x equals 5, and y plus 7x equals 9. So let's get y by itself in the first one, and that equals 3x plus 5. Divide everything by 2, you get y equals 3 over 2x plus 5 over 2. So my slope for my first one would be 3 over 2. Let's do our second one. We have y equals -7x plus 9, and that's all we have to do. So for my slope for my second problem would be a -7. 3 over 2 and -7 aren't the same. They're not negative reciprocals, so these would be neither. And that's how you would determine that just based on the equations. All right. Now we're going to use the slope-intercept form to graph our equations. So here's the steps that you're going to use to do this. You're going to, 1, write the equation in slope-intercept form. 2, you're going to find the slope. 3, you're going to find the y-intercept. 4, you're going to plot the y-intercept. 5, you're going to use the slope to then plot a second point. And 6, you're going to connect the points. We did this when we were graphing in 4.3. I just didn't tell you a slope-intercept form because all we were doing at that point was using the slope and using a point. And now if you have an actual equation, you can do the exact same thing. So I'll give you a second, hopefully, to write those down. Okay, let's do an example. Our example will be negative 3x plus 4y equals 8. And step 1 says we need to write this in slope-intercept form. So we need to get y by itself. So I'm going to add the 3x over to the other side. And then I'm going to divide everything by 4. So now I have it in slope-intercept form. Step 2 says to find the slope. So my slope would be 3 over 4. Step 3 says find the y-intercept. So that would be 0, comma, whatever my b is. And my b in this case is 2. Now step 4 says to plot the y-intercept. So here's my graph. And I need to plot the point 0, 2. So it means I'm not going to go left or right. I'm just going to go up till I reach 2. And then I use my slope to plot another point. So remember, slope is rise over run. So I got to go up 3. 1, 2, 3. And then to the right 4. 1, 2, 3, 4. Right there. And then I connect my points. And there's a graph of our line. All right, let's do another example. We have 5x plus 3y equals 12. So we need to get y by itself. So I'm going to subtract my 5x over. And then I need to divide everything by 3. I have to find my slope, which would be negative 5 over 3. And then I need to get my y-intercept, which would be the point 0, comma, and then my b is 4. I'm not going to graph this one because I don't really feel like we need to. The important part was determining that. Okay. Now, we've been going off of equations, but what if they don't give you an equation? What if they just give you a picture and they want you to determine the equation? Do you think you can do that? It's actually quite a bit easier than you would think. Here's a picture, and it would show you on there that this was crossing at 4 and this was crossing at negative 12. So right there you have 2 points. And that's really all you need in order to get an equation of a line. But the easy thing is we already know, we have just learned our our slope-intercept form. And so if we can write an equation that looks like that, it's really easy. Because if we're looking at this line, what is our y-intercept? Where does this line cross the y-axis? It crosses right here at that -12. So my y-intercept is 0, -12. Now, what in the world would my slope be? Because if you remember, our y-intercept would be 0, b. So right there we have our b. So the only thing left that we're missing is our m. So how do we find our slope? Well, we did this at the very beginning of 4.3, where if we're given a picture, we just have to kind of count. So remember, slope is rise over run, so we need to go up or down first, and then horizontally. So if we're going between these 2 points, and we start down here at this bottom one, how far up do we have to go? We have to go 12, because from here to here is 12 units. So that means our m equals 12 over, and then how far over are we going between this point and this point right here? We're going 4. So 12 over 4, and that equals 3. So our slope in this case is 3. With the slope and the y-intercept, we can we can determine the equation of a line. Because now we would have y equals m, and we just said m was 3, x plus our b, and our b is a -12. So right there you were able to determine the equation of a line just based on a picture, which I think is pretty cool, but I'm kind of a nerd. Okay, the next form that you're going to learn, and one that you're going to use quite a bit, is called the point-slope form. And the point-slope form is y minus y1 equals m times x minus x1. And in here, our m is our slopes, the same as usual, but the x1, y1 is a point on the line. So those are actually things that you would fill in. The only things that are going to stay as a variable are the y and the x that don't have the subscript. And we're going to do an example. Actually, we're going to do 2, so you can kind of see how this works. So the example says, write the equation in slope-intercept form. So slope-intercept form is the y equals mx plus b of a line that goes through the point 4, 2 and has the slope of 5. Okay, so we have a point, but it's not the y-intercept, so we can't just go straight to this form. So that's why we have to have this new form to use, this point-slope form. So we have some point on the line, and we have the slope. So we need to use this point-slope form. So we have y minus y1 equals m times x minus x1. Well, our point is 4, 2. So that's our x1, y1 point. So wherever there's an x1 in the problem, we need to put a 4, and wherever there's a y1 in the problem, we need to put 2. And then our m is 5. So we have y minus y1, which is 2, equals 5 times x minus x1 was 4. Now we just need to solve this equation for our y in order to get it into the slope-intercept form. So we have y minus 2 equals 5x minus 20, just distributed in our 5. Add 2 to both sides, and you get y equals 5x minus 18. And that is our y equals mx plus b form. Let's do another one. So now we need to get a line that goes through 6, -2 with a slope of 2/3. We're going to do this exactly the same way. We have the y minus y1 equals m times x minus x1. Y minus, and then the y1 is a -2, so that would make that a +2, equals 2/3 times x minus, our x1 is 6. Y plus 2 equals 2/3x, and then 2/3 times a -6 will give you a -4. Again, if you need a refresher on your multiplying by fractions, that's in chapter 1. I need to subtract over my 2, so give me 2/3x minus 6. And that looks an awful lot like my y equals mx plus b. So now we know how to find the equation of a line if we're given a point in the slope. We know how to find the equation of a line just given the picture. But there's one other instance that we might need to find the equation of a line. And that's if we're given just 2 points. So how to find the equation of a line given 2 points. Step 1. You need to use 2 points to find the slope, the 2 points given in order to find the slope. Once you find the slope, you need to do step 2, which is use one of the points that they gave you and the slope you just found and plug it into your point-slope form. Then you need to manipulate your point-slope form around into the slope-intercept form. Really, we were just doing steps 2 and 3. You just kind of have to add an extra step in there in order to find your own slope. Because a lot of the problems aren't going to give you a slope. It's just going to give you 2 points. And we're going to do one. So the example says we have the point -1, 3 and -5, 1. And we need to find the slope-intercept form of a line that goes through these 2 points. So our final answer needs to look like y equals mx plus b. But we don't know what m is, we don't know what b is, so we can't just use that form right off the bat. We don't even know what m is at all, so let's find m. So you might need to remember that m is y2 minus y1 over x2 minus x1. So we have 1 minus 3 over a -5 plus 1. And that equals a -2 over a -4, which equals 1/2. So now we have our slope. We know m equals 1/2. But we still don't have a b, so we can't use slope-intercept form. But we do have 2 points and a slope. And we just learned slope or point-slope form. So let's use our point-slope form. The y minus y1 equals m times x minus x1. And it does not matter which of these you use. You're going to get the same answer. It really does not matter. I'm just going to use the first one just because it's listed first. So we have y minus y1, which will give me 3. And then our m we just said was 1/2. Then we have x minus our x1 was a -1, so that becomes a +1. I need to distribute in my 1/2, so it'll be 1/2 x plus 1/2. I need to add 3 to both sides. So y equals 1/2 x. And then over here, if you want to remember, we have 1/2 plus 3. That'd be 1/2 plus 6/10. 2, which would be 7 over 2. So the equation of a line through points -1, 3 and -5, 1 would be y equals 1/2 x plus 7 over 2. We found our slope using our slope form. Then we used one of the points and used our point slope form, and we plugged it in, and then we just moved things around until we got down to our slope-intercept form, which is the y equals 1/2 x plus 7 over 2. Let's do one more, and then we'll do some homework. This is one of the more lengthy problems, but hopefully it's not too difficult. One thing I will tell you, a lot of times a negative sign will get lost somewhere while working these problems, and it'll mess up your problem, or you won't write your equation in point slope form. So please make sure you read your instructions very carefully in your homework. Okay, we have 2 points again. We need to find the slope. So slope equals y2 minus y1 over x2 minus x1. So we have 7 minus the -5, which will be plus 5. Then we have -5 minus a -7, so that would be a positive 7 on bottom. So 12 over 2 will be 6. So my slope is 6. And then we need to do our point slope form, which is y minus y1 equals m times x minus x1. Again, I'm just going to use the first one because it's listed first. So y minus y1 minus a -5 will be a plus 5 equals 6 times x minus x1. So that'll be minus a minus a -7. So it'll be plus 7. Y plus 5, distribute in our 6. Subtract 5 from both sides. And you should get y equals 6x plus 37. All right. Something you might want to make a list of is the different types of forms we have, maybe on your cheat sheet or in your notes. You have standard form, you have slope-intercept form, you have point slope form, and then you also just have your slope equation. If you don't have these memorized, it's going to take you a lot longer to complete your assignment, so I really recommend memorizing these because it's going to just really help out your math life and a lot of your science actually too. You're going to use this in your science classes. So I'd really, really, really recommend memorizing these 4 forms. Alright, let's go get your homework open. Okay, once you get your homework open to 4.4, I'm going to work, I think about 3 problems with you. I'm going to work number 1. Number 1 says find the slope in the y-intercept, and then it gives you an equation. Mine says y equals 2x plus 3. So this is already in the slope-intercept form, so you don't even have to do anything in this case. You just have to be able to identify what it is. So the slope of the line is, in this case, 2, because it's y equals mx plus b. Then it says the y-intercept of the line is, and it says type an ordered pair. You really need to be cautious of these things written out here in blue, because if you don't type it in the way that they want it, it's not going to give you credit. So an ordered pair is in parentheses, and then you have your x value, which is 0, and your y value, which is your b, which is 3. Then you have to make sure and close your parentheses. Hit enter. Excellent. That's all you have to do. You don't have to graph on this one or anything. You just have to identify. Let's look at number 3. Number 3, we have to use the slope and the intercept to graph the line. And you've already kind of done this. So we're given y equals x plus 5. So I'm going to enlarge my graph. And we know a point because we have the y-intercept. Our y-intercept in this case would be 0, 5. So that's going to be our first point. Going to go 0, 5 and plot that. And then there's not a number out in front of our x. And so don't let that confuse you and you think it's 0, because that means there would be no x, because 0 times anything is 0. That actually is a 1. Remember, 1 times x would still be x. So that means we need to go up 1 and over 1. And we'll plot that point. Hopefully that will be the correct graph of our line. Let's check our answer. We got it right. Okay, I'm going to go ahead and skip all the way down to 10. All of these in here are determine the equation of a line, or it gives you the point and it gives you the slope. So all you have to do is your point-slope form. We've already done quite a few of those in our notes. So I wanted to just skip down to number 10, because this one we have to determine the slope and our intercept, and then we have to graph it. So this one we have to do all 3. And it's not already written in slope-intercept form, so we have to, we have to actually do that. So let me pull up, sorry, I got my pages in the wrong order. To pull up the problem and then my paper. So we have a negative 6x plus y equals a negative 5. That's our problem, and we need to get that into slope-intercept form. So we just need to get y by itself. So luckily this one's easy in that. We just have to add our 6x over. So we get y equals 6x minus 5. So since we have my paper here, let's go ahead and identify our slope. Our slope will be 6. And then our y-intercept will be 0, comma, and then it's whatever our b is, and our b in this case is minus 5. Alright, let's go back to our homework page. Slope, we said the slope was 6. And then our y-intercept, again, notice it says type an ordered pair. So we have to do the parentheses, 0, comma, negative 5, close the parentheses, hit enter, and then it's going to give us a graph. This time we don't actually have to graph it, we just have to pick the right one. And if you can't see these, because they're small, you do have magnifying glasses. But I do want to point out one thing. Notice our slope was a positive 6. Back a few sections ago, I showed you 2 graphs, and I said this is what a positive graph looks like, and this is what a negative graph looks like. And to refresh your memory, a positive graph looked like this. So this was positive. And this was negative. And I told you it wasn't, a big thing if you didn't remember, if you didn't know this, just based on sight. But the reason why I gave you that information was for problems such as this, because you're going to be able to eliminate half of your answers just if you know whether or not you have a positive slope or a negative slope. So for this problem, we have a positive 6 slope, which means our answer needs to look something like this. So let's look at the 4 options. Instantly, we know it can't be B, because that has a negative slope, and it can't be D. That also has a negative slope. So it's between A and C. Now, our y-intercept was a 0, negative 5. So let's look at A. Does this have a y? Where's the y-intercept here? It's hitting right here. Is that y negative 5? No. That looks like 0, positive 1. So I don't think it's going to be A, but let's look at C to make double sure. We need our our blue line to go through our y-axis at -5. Does it do that? Yes, 1, 2, 3, 4, 5. It does. So our answer should be C. Check our answer. Well done. We got it. So that's how you do those problems. There are 2 other problems, and I'm not doing them because it's just determining if their lines are parallel, perpendicular, or neither. And all you have to do there is write them in y equals mx plus b form and then look at your slopes. And we did an example of each of those in your notes. So good luck on your homework and good luck on your quizzes.